Hello, my name is Thor Nielsen, and this is my final project for CST250, and it's the genome sort. So here's the flowchart of my genome sort. So the first thing I did was initialize my registers. I set S0 to the memory location of my array, the initial memory location. I used S1 and S4 as constants that I used throughout the program. So the first thing I did was I loaded the values from S0 into T0 and T1. T1 is 4 ahead of T0, which I use S4 to get. Then I check to see if T1 is less than T0. If T0 was less than T1, I would get a false indication, and I did not need to perform a swap. So I'd decrement the amount of elements that are within the array, and then I would perform another check to see if A1, which is the total elements of the array, is equal to 1. If it's not, and that it's not equal, then I loaded 2 new values into T0 and T1 and performed my check of T1 less than T0 again. If T1 is less than T0, that means I need to perform a swap, and I go into my swap function. So the first thing I did was store S0, the memory location, on the stack. I then stored the value in T0 into the current memory location pointer. I then decremented the array pointer and stored T1 into the current pointer. The swap has been completed in this section right here. I then check to see if S0 is equal to the beginning value of our memory location. If it is, then I know that I can't get any more values, so I recover the memory location S0 from the stack, decrement the amount of elements in my array, check to see if it's 1, load new values, and then check T1 less than T0 again. And again, when T0 is less than T1, then a swap needs to occur as the same procedure. Now if A0 does not equal S0, then I need to decrement the array pointer so I can load a new value into T0. Now if T0, then with this new value, if T0 is less than T1, we know that the array is sorted. So we can fall out, recover our stack pointer, decrement the elements in the array, check for 1, and load new values in the registers. However, once we decrement the pointer and load new values, if T0 is greater than T1, then we fall through and we have to increment the array pointer. So the array pointer now in memory is looking at 1 instead of at T1 instead of T0. So that way we can store the value of T0 into that position and decrement the array and store T1 into the current position. So this is how my flowchart works and how my program works as well. So here's the performance of my program. So with 5 array elements in order, it took 97 cycles. With 5 completely out of order, backwards, it took 211. And then these are just numbers to check to make sure that I can bring in any value and it'll sort it properly. So my average with these 6 is 143 cycles. So now we'll take a look at my code as it's working. And as you can see, it does pass, and all of them work like they should. The problems that I had with writing this code was deciding whether to use bit not equal or bit equal. And this was because I wanted to reduce the lines of code. And so I was trying to determine if I wanted to fall through to my subroutine, fall through to a routine, or jump to a subroutine. And the main area of this problem was in my initial check for my initial swap, because originally I had bit not equal, and when I had bit not equal, it added about 10 lines of code because I was having to jump to a subroutine and then jump out of that subroutine into the no swap. So that was probably the biggest portion of me trying to clean up my code. The next was determining if and when I wanted to use set less than flags. So the first one I checked T1 less than T0, and this reduced the code because I was able to fall through straight into a swap. While the second one, I used T0 less than T1, and this is because I wanted to jump out of that if they were equal, because I knew that I didn't have to perform any swaps. The next problem area I had was I was trying to use sub immediate unsigned. Well, I didn't realize that it wasn't the same as add in our reduced instruction set, so I got build errors, but that was quickly fixed by using a load immediate and sub use. The last one took me a little while to figure out, and that was why A1 had to equal 1 instead of 0. And it came to I figured it out pretty quickly, just because I knew that the pointer location was 1 ahead of what the array value or the elements in the array was going to be. So instead of it substituting all the way to 0, I only had to go to 1. When I did have it at 0, I was stuck in an infinite loop, and that's how, and using breakpoints is how I found that spot. So there's my program. Thank you very much.